All right, so let's continue. For the next, I will go into the basic protocols under the IPv6 principle. Okay, so under the basic protocol over here, we're going to go through some of the protocol. It's a very basic. We require IPv6 to run properly. For a normal data communication, we require all these basic protocols. So the first protocol we look into this is on the ICMP v6. Okay, there's the first protocol we look into. It's on the next headers is called 58. Okay, 58. And 58, that is your ICMP v6 headers. Inside the headers, you should have type and the code, as well as the checksum followed by your payload. So that is under the IPv6 ICMP v6 protocols. Okay, it's one of the basic protocol that we use to send the IPv6 node to report information about the packet forwarding or the error of the source node. So as a normal, let's say you can ping, you have request, you have reply, or you have a time exit, or you're going to have a destination unreachable, and so on. So they're going to send a different type representing a different functionalities, the detail of this type, as well as they can be sending the error, or they can send just like information. Okay, this information include like send the echo request like. So from this, they will have this. The type is from 0 to 127. 0 to 127 is related to the is an error message. Okay. 128 to 255. Okay, it's an information message. So they're going to divide it to two. So one is on the error. For the first half is the error message. Is on the information. So for this protocol, as I mentioned just now, the next header is 8. In your IPv6 headers v6. So inside the ICMP v6, they're going to use this function. The function such as ND, enable discovery, a stateless address configuration. Okay, stateless address configuration, DAD, as well as the path maximum transmission your view. This is your path MDU, EMU. All right, path need from one to the other end. So your path. That is all required ICMP v6 to send. They're using this form to send. Seems that when you're doing the D also need to this message type for you to provide. To set the type here is when you're carrying different information. On the next page over here, you can see that under the DMP typical type code are using 129 information message. Like you're going to send the echo request, echo reply. When you do a normal ping, just an information message to test the connectivity from one to others. It's called the echo and echo reply. For the error message, when you send the request, but you cannot get reply, then you give it the error, type 1, 0. 11121314 or 203031404142. So they give you the type and the code from here. The type 1 destination unreachable. Or destination unreachable because of the communication with the destination node administrator prohibited. So it is denied by the administrative. Okay, so they're going to give you the ideas about the reason why it fell of the destination unreachables. They have sub code inside this destination unreachables. And packet too big, that is on the path MTU. When they say that, oh, packet too big, what is your MTU size? Then you're going to put this information inside the ICMP data. What are the value I should define? When the path is too big, then in this case, that need to be set to the smallest of the MTU before we can communicate in between. Otherwise, the traffic cannot be forward. They need to go in through the path MTU before they perform the data communication. And time exit means that they are exit the hop limit. The hop count limit is 255. When they hit up to the maximum, then they cannot be accessing already. So they will show it as a 30 or 31. Okay. And number 4 is a parameters problem. It could be because of the error headers, the next type, and the IPv6 option. So that is on the 8 on the parameters problem. Some value are wrong. So that is on the side the IP. This type actually from type 1 they can go up to type 127. They're up to 127. But at the moment this is the common one. The common type 1, 2, 3, and 4. Alright. And the next one is on the information message. They have 128, 129. There's a normal ping. Okay, normal ping and respond. Yeah, that is purely using ICMP. This is a function similar to the ICMP v4 that we send as well. They just check the connectivity between the user, between the peers. All right. So okay for this one, this ICMP v6 information. Just give you some ideas on that. And next, we look into the NDP, Neighbors Discovery Protocol. Mention about the two and also router into messages. It come from ICMP. It's MPV6. Okay, using ICMP-v6 to forwarding the RS as well as the RA. It's after IPv6 address obtained to prevent the IP address conflict. It will be just similar to our GARP, contiguous ARP. Okay, to make sure that they have no conflict of the addresses among our link. So it's similar into v4, we call it as a contiguous ARP. Then the next one is on the address resolution. Under IPv4, it calls ARP, but inside the IPv6, they do not use ARP anymore. They're using NS and NA. Okay, sorry. They call NS and NA. Network solicitation and also network advertisement. So they're using NS and NA to provide the address resolution. And this is what we're going through as well to check how they're using NS and NA to perform the ARP, the address resolution. And next is on the neighbor tracking. The neighbor tracking, it discover the neighbor on the link through the NDP and trace the neighbor status. Okay, you can grab this information from the neighbors based on the MAC address of the neighbors and corresponding entry stored into the v6 neighbor tables. So they're going to keep my neighbor information inside the neighbor tables. That can be done. They can be perform this NDP to discover your neighbor get what your neighbor MAC address, what your neighbor IPv6 address, all everything keep inside the neighbor tables to tell who is my peers. And the prefix readdressing. The router flexible set the advertised address prefix to implement network readdressings. So you can set the network readdressings by using RS and RA as well. Hosts can automatically generate their own IPv6 by adapting the prefix. So I just have to get the prefix from the routers, and the interface ID I generated myself by using the EUI64. Okay? It can be done under the prefix readdressing. You can just sending your prefix to the rest. The interface ID, you just leave it to the user, the host. The host can do it themselves. And the route redirection. This one will be just similar to the ICMP redirection. Okay, inform other device of the optimal next hop to the target network. So it means that when you are going to the destination, but you're passing through me and going back to the same direction, it means that that is not the best way. I'm going to tell you that for you to go into this, your best way is for the next routers. It's not going to me. I will send a route redirection back to you to ask you to point to a better next hop. Instead of point to me, you point to the better next hop, go to that destination. So it's just like the ICMP redirection. When they figure out they have a better way, then they will use the redirection to redirect the route back to the host to ask the host, next time when you go to this destination, point to the next hop specified by the routers. I give you a next hop for you to reach to this destination using a preferred path. Do not send this information back to me anymore, because going through me, it's just going through the suboptimal way. So you should go direct to the destination. Okay, that is called the route redirections. So this is on the NTP that can provide router discover stateless auto configuration, DAD duplicate address detection, address resolution, neighbor tracking, prefix readdressing, and as well as the route redirection. So from here, this is on the V6 packet, IPv6 packet that we use into the NDP. But they're using all the ICMP v6. They are using the 133, 134, 135, 136, and 137. That's all the informational message. Okay, it belongs to the informational message because it's from 128 to 255 informational. From 1 to 127 is purely just a error messages. So they have a router solicitations, router advertisement, neighbor solicitations, and neighbor advertisement. NSNA, NSNA. Okay, RSRA and NSNA. For RSRA is purely more to the prefix advertisement and prefix readdressing. Okay. For NS and NA is more to address resolution and also DAD. Okay. Sorry for a while. Let me just give me a second. I pause a while. Sorry. All right, sorry about that. So just now I'm talking about on the RS and RA and NSNA. So the last one is on the redirection. Redirection is meant for the route redirection. So that is on the ICMP v6, the port numbers, the type numbers they're going to use inside the IPv6. So they're going to have extended ICMP v6 information. You can see that the ARP is here. Okay, ARP, the GARP, they do not using the dedicated ARP message anymore. They're going to use the ICMP, they integrate this information into the ICMP and perform the address resolution and also doing the detection of the DAD. So they just change the method. Instead of sending broadcast right now, I'm going to carry this information inside the IPv6, sending using the ICMP v6. Okay, by sending the NS and NA, neighbor solicitations and also neighbor advertisement. These are the messages they're going to be sent to grab the information from the destination. So we're going to check one by one. The first one you check is on the address resolution. How they perform the ARP from the IPv6. Let's have a look how the process has been done. So IPv6 does not support address resolution protocol or any broadcast address. So for them to perform this address resolution, they need to use another method. So that's why they come up with the NS and also NA, 135 and 136. So under layer 3 address resolution enable different link layer protocol to use the same address resolution protocols. So that is what it means. This ARP is belong to a layer 3. Okay, how they're going to use a different link layers protocol to get the same address resolution protocol, they're going to implement the ICMP v6 to doing so. Because ICMP also on layer 3 as well. So instead of I going to do it above a layer 2 right now, I do it above a layer 3. Under ICMP v6, I perform the address resolution. Because you remember that under a layer under the IPv4 ARP, where is the layer for this ARP information? So normally that we send the ARP, when send ARP request. Okay, so I should have seen this my ARP message followed by a frame. Okay, behind is a FCS. Okay, so that is the things that include. So in front of this, they do not have any layer 3. They do not have adding layer 3 in between. There are no IP headers. So inside the frame, we have destination MAC. We have a source MAC. Okay. Inside the ARP message, they have a source IP, destination IP, source MAC, and destination MAC. This is what information inside the ARP data. For the frame, you have destination and the source. So that is where you're going to get this. Okay. But right now, under IPv6, they do it inside the ICMP v6. And in front of it, over here, you have a IPv6 headers. Okay, they do it a layer uppers. They're not doing it on the layer 2. They do it on the layer 3. Layer 3 address resolution. Okay, that's where there are the difference between the v4 and IPv6. Okay, IPv4 is doing it just above the layer 2, but IPv6 is do above the layer 3. Okay, by default, the ARP request packet is sent in the broadcast mode. So it will be flat to all the hosts on the layer 2. Okay, but under the layer 3 address resolution request will only be sent to the solicited node multicast group. You remember the group that I mentioned? That is the group solicited node multicast group. Only within that, whoever enable this, they can receive this. So they're using the bit of 104 bits, FF02 : 1FF. Okay, that is where they come from. Okay, where they come from. They're using this method to send only to dedicated user. Okay, so which address you be resolved belong to, I will put into this. And the transmission in the multicast mode, it greatly reduce the performance pressure. So you do not have a lot of messages if we keep on sending like a ARP request. Because a ARP request on V4 is just broadcasting to everybody's. Okay. For this layer 3 mechanism, you can be used to prevent address resolution attack as well when you enable the IPsec encryption of the information. In this case, you can prevent that the attack of the resolution attack. Okay. The sending NS is more using a multicast mode is more than the more efficient than the broadcast and reduce a lot of pressure compared to the layer 2 performance they provide. All right, so that is the way how the address resolution they come together. They're going to use the solicited node multicast group there to handling this information. So for the address resolution packet, how the packet it look like inside this ICMP v6. ICMP v6 is pretty simple. They have type, they have code, they have a checksum, and that is on the payload that you have. Okay, they have payload. Your ICMP data is inside. So it's pretty simple like this. So they have TNS and NA to be sent. They have two types of the ICMP v6 packet are used during the address resolution. Okay, the solicitations and also the neighbor advertisement, NS and NA. So the type is 135. 136 for NA, the code are 0. They do not have any subcode in this case. Okay, they have no subcode in this case. For the NS, target address is the IPv6 address to be resolved, which cannot be a multicast address. Okay, that is where's your target addresses. Your targeted addresses, it means that the addresses you want to refer to. What are the destination that you refer to get the multicast IPv6 MAC address? Okay, that's what you want to get. Based on you put the targeted addresses and to trigger, I want to resolve this target address MAC address. Okay, so the targeted the link layer address of the NSN is encapsulated into the option. What type of encapsulation they are using? Okay, that is on the NS. Advertisement it is some sort of the reply. Okay, the R flag and S flag and O flag. They have router flag, solicitor flag, and also an override flag. So R flag indicate whether the sender is a router. If the value is 1, then the sender is a router. When S is whether the neighbor advertisement packet is sent to respond to a neighbor solicitation packet. If the 1 is 1, means that it's just a response of your NS. Okay, this is just like the ARP reply. And the O flag is an override flag. Indicate whether information in the NA packet override the existing information in an addresses. If the value is 1, the existing information will be overridden. Okay, override your existing information has been overridden. The target address is indicate the IPv6 corresponding to the link layer addresses. So that is where you're getting your information. Okay, so using the address resolution packet, that is a format inside the ICMP version 6. So when you go into the address resolution diagrams, this is how it look like. So we will have a PC1 and PC2. Okay, PC1, I have a 2001::1. This is my IP address. 2001::2. This is a PC2 IP address. I want to get request. Hey, what's the MAC address for the 2001::2? Because I need to send traffic to you. I need to grab what is your MAC address. So in this case, I'm going to send the ICMP v6 NS. Okay, I send the NS. So under the NS, this information over here is on the source MAC address. This is my source MAC address. It's 1111. This is my source MAC address. And I'm going to trigger that, hey, this is the solicited node multicast address. FF02::1:FF00::2. This ::2 is representing that they're looking for the 2001::2. They do not need to know about the prefix in front of here. They only need to know only the 2. When you are the 2, you need to respond back to me. Okay, when you are the 2. Okay, because for this address resolution is always inside the same prefix already. So when I want to set the destination, I just put the destination address inside my layer 3 headers. I have this. This is my destination. Okay, the FF02::1:FF FF0. This has been fixed. This has been fixed already. This is called the solicited node multicast address. And behind, I will just add as a 2 of your interface addresses as 2. Then I'm going to send this as a multicast address to only to this person. Only PC2 you get response back to me sending the NA. Okay, send NA to tell me that this is your MAC address. Alright, and you can see on the layer 2 headers that is a MAC address. MAC address has been fixed for 3333-FF00-0002. Okay, that has been the MAC address on the multicast MAC address of this. Okay, so they map this back into your multicast address. Okay, this is how you're mapping. The first 2 bytes is always fixed. Then convert this into the multicast MAC address. That is where I'm sending through. This is on the address resolution, how they send across to the PC2. Is it okay so far up to this point? How they send in the NA. This is above layer 3. IPv6 headers. Okay, this is under the extensions headers of 58. Okay, ICMP v6. Okay, so it means that it's above IP layers. For IPv4 is above layer 2. So that is the differences. So you need to grab the differences between the v4 ARP and v6 address resolution. What are the differences? When I send RA already, so you should send me back the NA. So you send NA, this is NS. When this receives, oh, that's me. I'm colon 2. You are looking for the correct person already. In this case, when I send back to you, I will send as a unicast. Just now I send this as a multicast. Okay, you can just refer based on the destination MAC address. You know that this is a multicast and this is a unicast. Okay, so in this case, inside the ICMP v6, the 136, inside they will have a destination addresses, and also this is the MAC address. Oh, colon 2, my address, this is my MAC address. I tell you that, oh, right now 2001 colon 2 MAC address is a 2222. Okay, I'll let you know. This is the information inside, and inside my layer 3, it will be just 2001 colon 2 sent to 2001 colon 1. Because I already know where you come from. You've come from 2001 colon 1. I just send you the unicast from the source of 2001 colon 2. I send to 2001 colon 1. And the MAC address over here, when you send to me, I learn your MAC address as well. You come from 1111. Myself is 2222 as a source, and I go to the 1.1.1111 and send back to you. So that is sending as a unicast. So that is how a simple way of the address resolution. So they have going through round and round. Okay, that is how the NS and the NA they perform. And especially that you need to be aware, this is called solicited node multicast addresses. Okay, the first 104 bit are matched, are the same. Okay, it's always a FF02 colon 1 colon FF00 followed by the interface ID that you're using. Okay, that is on the address resolution. So far, okay? And for the next one is on the IPv6 neighbor routing tables. These neighbor routing tables, unlike for the v4, v6 does not use the ARP table to catch the mapping between the IP address and the MAC address. So they do not you cannot check the ARP minus A. Okay, ARP minus A is just on the IPv4. So from the V6, you need to check the neighbor tables. You can using the display IPv6 neighbors when I'm able to discover who you are already. So I will say that this is my neighbor 2001 colon colon 2012 colon colon 2. This is a link layer address. Okay, this is my IPv6 address. These are link layers addresses and so on. So it's going to show you the detailed information inside your neighbor tables, IPv6 neighbor tables. So all the status over here, what's the status they will have? Okay, they have different state over here. They have incomplete, reachable, style, delay, or propped. So over here, let me just explain to you what are the neighbor state they show from here is what it means. Okay, what it means of these functionalities. Inside the actual communication, a neighbor tables need to be maintained to monitor the state of each neighboring device, and transition between the state is allowed. So they need to keep this information to make sure that I still can be reachable. If it's not reachable, I need to send the NS and NA again. Okay. So therefore, there are 5 types of a neighbor state. Start from incomplete. Under incomplete, the state indicates the NS packet has been sent to the solicited node multicast address of the destination node, but there no NA has not been received. I sent, but no reply. Okay. And reachable, the state indicates the neighbor is reachable and no packet need to be sent for confirmation. And reachable means that everything is good. Style, that state is indicated that more than 30 seconds has passed after the last reachability acknowledgement was received. It means that it's ideal already. When it's ideal, you go to the stale. The stale is for 30 seconds. After 30 seconds, the traffic passing through, let's say 30 seconds is ideal, they go for this state, a stale state. And the delay, the state indicates the packet is sent when neighbor is in the stale state and no reachability acknowledgement is received within 5 seconds. Then they will get a delay state. And the prop state, the state indicates that the NS packet is retransmitted every 1 second to detect reachability until an acknowledgement is received. Okay, make sure that you get me the reply. Otherwise, I will just go back to the remove your entry. When you not apply the acknowledgement back to me, it means that the neighbor is already lost, is losing already. So in this case, I go back to the remove all the entry inside my tables. Okay, these are the 5 different type of the state that you need to grab the ideas. And now we look into the how this state changes, how the state from changing from one state to the another state. So first start is from the MD. Okay, from MD state. From MD state, it means that you're not learned anything yet. So just like your ARP table is nothing before you accessing want to try to go at one other destination, then only you get information inside. Otherwise, it's just empty. Okay. So for node A, you send a NS message to the generating a cache entry. Then the neighbor state of the node A, you become the incomplete. When first node A send NS packet, you go to the incomplete state before you get replied from the NA, from the router B. So if router B reply an NA message, then the neighbor state you'll be going to the reachables. From incomplete, they go to the reachables. So otherwise, the neighbor state message, the neighbor state will be changed from incomplete to the MD. Okay. Let's say let's say I did not receive any NA packet, I will go back to the MD after 10 seconds. Let's say I not received any NA packet replied. Okay. Then in this case, this entry will be removed. I do not require this entry because nobody reply me back. That means that I have no neighbor of this. So after the neighbor are reachable, 3 seconds, 30 second timeout, the neighbor state will be changed from reachable to start. Okay. 30 second pass, or the solicited node is received from the node B. Okay, they go to the start node. And after that, node A need to send data to node B. Okay. If node A is reachable state, then they're going to send the NA message from node B, then the link will be going to be able to activate it due to the delay. Okay. If there is NA is reply, then they will go back to the reply. Otherwise, they will delay and plop again. They keep on plop. Let's say you have no reply, I keep on send every second to ask, hey, are you reply me already? When you reply me to already, you go to reachable. Otherwise, I will go back to the MD and remove the entire information. I will not form with you anymore. Let's say you do not prompt anything to me, you do not send me the NA, I consider you are not there. So the state over here, you will not become the reachable anymore. You get back to MD. So reachable, it means that it's a active state. They are activating, they are running state. When after 30 seconds, they have no traffic going across, then they're going to go to the style state. By the time they're going to use again, they go to delay and wait for the NA, then they go back to reachables. Okay, just similar to the ARP, when you're not using for 5 minutes, they will age out. So before they age out, they'll keep on try whether this is still needed or not. Let's say needed, I would just extend the expiry. Similar to this as well. But this method is just different. They're just using the NS and NA to handling. Okay, for solicitation and also the advertisement from A to B or B to A. So it depends on where is the communication going on, where is your neighbor connected from. Okay, that's how the neighbor state we can create it inside our IPv6 neighbors. Okay, inside the IPv6 neighbors. This is called the neighbor state changes. And the next one is on the DAD. It's a DAD, duplicate address detection. How am I going to detect the duplicate address detection inside my environment? Same case, they are using the solicited node multicast address, the FF02::1:FF00. Remember, that's the address that we're going to use to detect on the DAD. So DAD is ensure that there are no two identical unicast address on the network. Make sure whichever I have, nobody has configured the same address as mine before I can use it. DAD is required for all addresses, and NS and NA packet are involved into the DAD process. It means that the DS 135, 136. These are the two coding that we are using inside the DAD. So they're very similar to the address resolution. Okay, the NS and NA. For the implementation, for the IPv6 address assigned to the interface but not verified by DAD is called as a tentative address. Before you are verified by DAD will do it at the background. They want to check, just like a quantitative ARP. When the interface come up, I need to check whether you have duplicate in my network or not. Let's say yes, I prompt. So, but for IPv6, they give you say that this is a tentative address I want to use, but it's not activated yet. Okay, I need to go through the DAD before I activate these addresses. So I call this as a tentative address. Tentatively, I'm using this address. But before I can permanently use, I need to make sure in my network, nobody configures same as mine. So the interface cannot use the tentative address for IPv6 unicast communication, but will join to the solicited node multicast group. Okay, so it's not been used yet. You need to join to the solicited node multicast group to send out, hey, any same address with mine. Let's say yes, then you reply to me. I will just keep up to the tentative address. So a node send an NS packet to the solicited node message multicast address group where the tentative address belongs to. If the node receives an NA reply from other side, the tentative address has already been used, and this node will not use this tentative address for communication. So you can't use because this address has been used by others. Let's say you get a NA reply. Let's say you did not get NA reply, it means that okay, you are safe to use on this information. Let's say someone reply you as a NA to tell that, oh, I'm using this address as well. Then in this case, you cannot be using this. Before assigning any IPv6 unicast address to the interface, including the link locker address, you need to perform the DAD on the interface. So they will do it themselves. They will do it automatically when you configure an address. They perform the DAD. So how the DAD process has been performed? It will be something like this. So first, when I created I assign this address 2001:FFFF. This is my interface ID. I created already. In this case, this address will be joined into the solicited node multicast group address as a FF02:1:FF00 FFFF. So in this case, this is the multicast MAC address, and this is my source address. So inside the ICMP 135, that is the information that I have. Inside the NS, the destination address is 2001 : FFFF. This is what I'm going to ask. Hey, is anyone using the same address as mine? So in this case, this information be forwarded using this multicast address, forwarded to already. When order B received, I check. Okay? FFFF, that's me. I open up and check. It's the same as mine, so I send you the NA. Destination address 2001 : FFFF and 5E 8998502222. I will tell you that, oh, you want to, this is the MAC address I have. So when this compare, this MAC address, they compare with this MAC address. It's not matched. It means that it's duplicating already. The duplication happen inside these addresses. So you can't use this address anymore when you get a duplicate NA message reply. Okay, when you send the NS, you reply with NA, it means that this address cannot use for communication. They will start as a tentative address. You need to manually assign this address to a new address. So they will give you a keyword, it's called duplicate. Okay, they will say that it's a duplicate. Then you have a duplicate next to your address. Okay, 2001 : FFFF 64. So right now you have a duplicate address. This is something how it look like on the observe. Let's say observe on the R1. This is how you get on this address. Is duplicate. You have duplicate of this address. You cannot use. You need to reassign an address. Okay, reassign a new addresses that is not duplicate. Okay, that is on the DAD observed on R1. So this is on how it DAD. DAD and also address resolutions. They are based on NS, NA. Okay, this one you can consider as a request. This one is on the reply. Okay, you can see that just now the reply over here, the destination over here is going to where? To everybody. FF02 : 1. Because I cannot say that the destination is back to FFFF. Because you have no address defined yet. Your address is just a tentative. I cannot use as communication. So in this case, I will just send to everybody to say that, oh, this address as a FF02 : 1 is to all nodes in link locals. Because it's 2. That's 02. So I will send to all the link local address. Everybody you receive in the link locals, you get this information. Okay, and this is a multicast address. So that sending this is multicast. Reply is multicast. Are different compared to the address resolution. Address resolution, sending multicast, reply as a unicast. Okay, that is the differences that you might need to grab the ideas. Okay, request and reply. So how they're sending and reply back the information. And next one is look into the SLAAC. SLAAC. A stateless address auto configuration. Okay. SLAAC. Stateless address auto configuration. So that is on the standard IPv6 function based on RFC 2462 is very standard. So any vendor, they should support this stateless auto configuration. In the V6, a device can obtain IP address dynamically or through the manual configuration. In the dynamic address obtain mode, DHCP V6 and the stateless auto configuration is available. So DHCP V6 is called a stateful. Okay, a stateful address auto config. Okay, that is on the stateful. For stateless, that's what we're showing here. So compared with the DHCP V6, SLAAC does not require an application server and is more lightweight compared to the DHCP V6 because they just need to send the RS and IA. So after receiving an RA message from the switches or routers, the PC puts the prefix and use the 64-bit host suffix, e.g. EUI64, generated locally to an IPv6 global unicast address. So I just have to give you, this is my prefix information. I have my prefix of 2001. Behind is just my MAC address, 64. So I can be just assigned something like this. In these addresses, it can be manually defined or using the UI64. Okay. So for this SLAAC, they do not include the interface ID. Interface ID is up to you what you want to use, but I provide the prefix ID. Okay. So I provide the prefix IDs. So in this case, after this stateless auto configuration is enabled, a V6 address does not need to manually configure, and the device is a plug and play. You plug in, you can use already. You do not need to think of what IP address are going to be defined on these devices. It's not required. It's just plug and play when you enable the stateless address auto configuration. So the host automatically generated the link local address of the network adapter based on the local interface ID. They do it their own algorithms. And the host perform the DAD on the link locals addresses. If no address conflict, the link locals can be used already. Okay. And the host send RS message to discover any V6 routers on the link. The source address of the message is sent to the link locals of the host. Okay. When there's nobody, they check whether any routers. When router will send me the RA. So in this case, I will send the RS first. I will say, hey, I'm the host. I require to check any routers in my link layers. Let's say yes, I will send you the RA with this information. Okay, with the prefix information. When I grab the prefix, I'm going to generate my addresses, my interface ID myself based on using the EUI64. Or you can also manually define what interface ID that you want to use, but the prefix just follow what you learn from the routers. Okay, that is one of the way to getting the address from the routers using the stateless address automatic configuration. Okay, that's one of the methods using the SLAAC. Otherwise, you can use back the DHCP V6. But for using DHCP V6, you need to have a server, and the server needs to be reachable to all the user. Therefore, them to send the request, reply, and so on. Okay, that is a bit complicated. Compared to this, it'd be much more simple on the assigning the prefix information to all the hosts. And next is on the router discovery overview. Okay, router discovery overview, they're using the message I mentioned using RA and RS, 133 and 134. Okay, 133 and 134. RA is called router advertisement. Each router periodically send multicast RA message carry network prefix and identifier on the network to declare is existing to the layer 2 hosts and devices. A RA message has an ICMP field of 134. I keep on sending to tell that I'm the routers. Let's say you define yourself as a stateless auto configuration already. I'll keep on sending RA message to alert everybody. This is my prefix. You need to generate your own interface ID to configure as your IPv6 address. This on the RA. RA will be sent by the routers or the switches. NS, router solicitations. After being connected to the network, a host immediately send an RS message To obtain network prefix, device on the network reply the IS message, and IS message have the 133. So this is when the host join to the network. They will immediately send IS. Anyone know what's the prefix we are using in our network? Let's say you know, please send a acknowledge back to me. Send back to me. Send the advertisement to me to tell that what is your prefix. I have to follow what you define into the prefix. 2001, 2002, 2003. So you need to know what is the prefix you define from your site. Okay, this is on the router discovery overview. And next is on the router periodically send RA message. As I mentioned, they will send every 10 seconds. Okay, send every 10 seconds. So how does the host obtain the information include the network prefix? They have two methods available. A host can direct obtain the information from the NA, from the RA, or a router send an RS message to a router and wait for the reply for RA. So somehow this information need to be get from RA. The host, when you join, you can send RS to request. Otherwise, you can just wait for the RA come back to you. Okay. Router on the link periodically send RA message. What is included? They have a 134. The type is RA. Router link local address or node multicast address FF02::1. Okay. Router lifetime, current hop limit, auto config flag, option, prefix, and MTU, and so on. This is what normally they would send by the routers to the user, to the host, into the link layers environment. So a host that receives the RA message is added to as a default router list. A router that receives RA message check the RA consistency. Okay, see whether which one is the correct routers. Let's say you have two routers in this environment. I need to discover who is your neighbors. Okay. And router reply with the RA. So when I send RS, so RS 133. When I send RS, you see that I send to FF02::2. What's the difference between FF02 and FF01? FF02::1 is for all nodes, all the hosts and all the routers. But FF02::2 is meant for all the routers only. I only send to all routers. When routers receive this, I will send you the RA to inform that what is the prefix I'm using. You also can point me as your gateway. The reply RA message can be sent out to requesting host in unicast mode or to all nodes in the multicast mode. So it depends. This can be a unicast or multicast. When they send back the RA back to the host, that can be a unicast or can be a multicast. So that's on the router discovered when they reply the RA messages. Okay. And when you're getting this information, when you obtain this prefix or other parameters, what are parameters we can send this information? We can getting from the peers, from the routers. If the following condition are met, the prefix in the RA message can be ignored. So you can just ignore it. Do not need to be followed. The auto field in the RA message is displayed as a 0. So it means that you did not define as the auto configuration. Okay. So over here, they did not show. They should have a code to display either is 0 or 1 under the auto field. And the prefix is the same as the on an existing addresses, including the link local address. So it means that let's say you're already having these existing addresses already. So I will just ignore your RA message. And if the RA message, the value of the preferred lifetime is greater than the valid lifetime. Okay. Normally, it's valid lifetime greater than the preferred lifetime. It's not the other way around. Okay. And the sum of the prefix length and the interface ID length is not up to 128-bit. You also ignore. You will not entertain this RA message when this condition is met. I will ignore this information. Except the preceding condition, a host obtain the following time parameters when obtaining the prefix. So they're going to have a preferred lifetime and also a valid lifetime. So they have two lifetime. For the preferred lifetime, it means that it's a validity period for a new communication, like a new TCP connection, a new HTTP connection. They're going through that direction. When I go up to the valid lifetime, you can't define a new lifetime anymore. You cannot create a new communication. Okay, it means that your addresses will be deprecated. Okay, later we'll mention about based on the lifetime parameters. And the host periodically receive RM message and update its time parameters based on the receiver RM message. This RM message keep on renewing until, let's say, I not receive anything. When my time expired, this address will be removed. I can't use anymore. So they have a lifetime for every single address you obtain by the stateless auto configuration. When an address is in the deprecated state, it cannot initiate a connection, but only can be connected. It can connect it, but you do not able to create a new connection anymore. This address is going to be invalid soon. The design ensures that the upper layer application, however, the address become invalid after the valid lifetime up to the maximum, then you go to invalid. So the address always is start from the tentative. When it pass through the tentative, it's called a preferred. After preferred deprecated, then in this case they go for the invalid. So that is a state of the lifetime that we have for the addressing that you collected from the RM messages. So when you receive RM messages, the time will be reset. So it means that you still can use this address for this preferred lifetime period. Okay. When I say you do not receive RA for long times, then they might go to up to the invalid. When they exceed the valid lifetime, then they go to the invalid. Okay. That is on the lifetime parameter that we have. We have preferred lifetime and also valid lifetime. The flag field in an ICMP v6 RM message. So where I focus over here is we have this is on the current limit. What is the current hop count limit? So the field on the number hop count of the host after a PC use the prefix advertising in the RM message to construct the v6. The hop count limit of IPv6 will be set to 64. Okay, it's set to 64. This is why they set based on your prefix they define. And then over here, they have an M value. This is the M value. Manage address configuration and also other configuration. Okay. Under the default, the M value is 0. When 0 is used, the host that receive RM message use the IPv6 prefix contain the RA message or for the stateless address auto configuration. So it means that they have M and also 0. When M, then when used, bit is 0. Default bit is 0. When 0 is used, that means that they're running on the stateless address configuration. And run the following command to set the flag. Anti-auto configuration management address flag. If this is set to 1, the host that received the RM message use the stateful auto configuration that is using DHCP. So we have a M, 0, and 1. When 0 is a stateless. Okay. When 1 as a stateful. Stateful, it means that using the DHCP v6. This one using the SL AAC, stateless address auto configuration. Okay, 0 and 1. So that's on the manage. We also need to concern about on the old. Okay, others. Okay, others configuration. On the next page over here, under the other configuration, the default value of other configuration is 0. Indicate that the host should not use a stateful auto configuration mechanism to configure other parameters except the IPv6. Okay, you can run this command to set to 1. IPv6 ND auto configuration are the flag. The host then use the v6 to configure other information except the v6 address, such as the DNS and also a domain name. So in this case, they have other configuration to create the information like DNS, a domain name, and so on. They can be gathered from the DHCP v6. Okay, so it means that you can have M, 0, M and O. This is on the stateless. This is on the stateful. Okay, and the unit is in a second for router lifetime. Okay, this host consider the value of the default router lifetime. When router lifetime is set to 0, the router will execute excluded from the default gateway list of the host. Means I will not be your routers. I cannot be a router anymore when this is a 0. Okay, that is on the field inside the ICMP RA message. Okay, RA inside the flag. These are the two common things we need to know. Okay, the M manage address configuration and the O other configuration. Either you can get it from the stateless or can get it from the stateful. Okay. So for this is on the prefix itself. They have a flag from here. One is called the on-link flag or the autonomous address flag config flag. This default value of the L bit is 1, indicate that the prefix is in the RA message is assigned into the local link. Okay, local link is not going to externals. Therefore, note that send data to address containing the specific prefix contain link as a destination. Okay, that is always be as a local link. You can set these parameters to back to 0 by attending this IPv6 NARA prefix 2001 or the address that you have offline. Okay, off link. Okay, you off this, it should be 0. So this is how we can set. But normally we're not doing this. Okay, and this default value for the autonomous address config flag. Okay, the A bit over here is 1 default and indicate that host on the local link can use the prefix for the stateless auto configuration. If the value is 0, the prefix cannot be used for the stateless auto configuration. To change to 0, let's say you do not want to support the stateless auto configuration, you're going to do this. IPv6 NARA prefix 2001 : 64 is the prefix. This 2592000 is your valid lifetime, and 6048000 is a preferred lifetime, and set that no auto configuration. So this is disable the stateless. So I don't follow your prefix when this as a 0. When it's a 1, it's a default, means that I will follow whichever that you send to me as a prefix address. So this one is inside the RA. So RA be a bit more complicated compared to NA, the neighbor advertisement. The router advertisement, they include more information from here. Okay, so they manage address, other information. Okay, and also they have all this valid lifetime, the host lifetime, and so on. Okay, they have a preferred lifetime and valid lifetime. This all will be shown from here. So far, okay. So this on the flag on the ICMP-v6 RA messages instead of RA messages. And the next one is on the redirection packets. For redirection packet, when a better forwarding path is available, the gateway router send a redirection message to notify the host. The structures of the redirection packet is as follows. This is reserved. They only have target and destination. Okay, so they tell you that what is the better target and way to go to the destination. So something like this. They have the XML from here. For target address is the next hop address for the better path. Destination address is just that the address to which packet are redirect to. Okay, where is the destination that you need to redirect up to? And this is one example here. The default router of host A is router A. Okay, this is default gateway. When host A need to send data to host B, how they send? Okay, so when host A want to send to host B, so which path they're using? Because RTA is my gateway, so by right I should go to this way and go to this way. By right I should go to this method, right? Because you are my gateway. Let's say that right now, this is how I can tell that this is how you go. But based on router A, they detected that for me, for router A go to the host B is something like this. This is the best way for router A to go to the host B. Yeah, this is the best way for host A go to host B. This is host A. So in this case, when router A know that when the traffic coming in on this interface and going out from this interface again, it means that the path are not going through the optimal way. You are not using optimal way to reach to the host B as a destination. So in this case, from here, router A, you send the route redirection back to host A to tell that, hey, I'm going to send you a redirect packet to say that don't use RTA, use RTB. Destination is host B. So I ask you to point to this next hop going to the host B destination. So next time when you want to go to host B, don't point to RTA. You should have point to the router B instead. Okay, that is where the redirection process they need to be performed. Is okay? One more time, huh? So RTA, the best way, this is how they are forwarding to host B. That is the best way. When host A want to go to the host B, so my gateway is router A. So I should go all the way to router A, come into this interface, and go out from this interface. Okay. So when in and out is the same interface, router will send the route redirection to host A to tell that when you go to the destination of host B, use the next hop of RTB. Okay. Okay, use the next hop of RTB instead of go back to me. So in this case, the next time the packet they be forwarded after I reply back to you, that's the traffic how it goes. Router B and destination. Okay, this is what the redirection can be done for you to redirect the traffic, go to the optimal way. Okay, let's consider on the redirection. Okay, redirection. Is it okay? The redirection process. Okay, next. The next one is on the PMTU. The path MTU. It's a minimum interface maximum transmit unit on the path. So it means that let's say right now, I have 1005, 1005, 1004, and 1003. So the path MTU discover protocol is defined in this IFC 1981. So when I have this, I'm going to set, I will send the ICMP V6 and to go to set, hey, this is my path MTU 1005. Okay, but this router is okay. So up to this point, then this give me the error. ICMP V6 error number 3. Okay, it's too big already. The message is too big. Do you remember based on what I mentioned just now? On the ICMP message type, or this 2. Okay, it's 2. Packet is too big. This is where they come from. Okay, packet is too big. Okay, packet is too big. So in this case, they were going to give the error of the ICMP message of the code of number 2 to tell you that, oh, right now it's too big already for me. So in this case, okay, when it's too big, you inform me that I can only support 1004. I can reduce. I send the path MTU. Okay, I agree. Let's change to 1004. But when up to this router again send me that ICMP V6 error 2. I only support 1003. Okay, fine. I will send PMTU 1300. So they're going to keep on lower down, lower down, lower down until to the agree value between the two nodes, source and destination. They must agree one of the PMDU. So in this case, the PMDU will be 1300. Okay. So this is on the animations. So it said that, oh, packet is too big. Use the MTU 1004. All right. Then it said, oh, it's too big. Use 1003. Then last, I will use 1003 as a PMTU 1003. So make sure that both are agree using 1003. You send me acknowledge that I received. Okay, let's agree. We use 1003. Anything more than 1003, we will fragmentize from my source. Okay. So that's why this is a better compared to IPv4. It's hop by hop. It's hop by hop MTU. So it means that your fragmentation can be in the middle of the devices. Okay. Let's say suddenly in the middle device you have a 1002. All the while it's 10,005. But suddenly on that device, you're going to be 1003. So you'll be fragment on the middle device. But for this path MTU, it'll be standardized. They're going to perform from the source up to destination to discover what are the path MTU we should use between the source and the destination. Is that okay? That is on the path MTU. They need to negotiate on this MTU before they are sending the data communication. Is that okay so far? Okay. So the minimum path MTU is 1280 byte. That is the bare minimum I can include. Okay. The minimum MTU support by IPv6 is 128 byte. It cannot be anything smaller than this. Okay. Anything smaller than this, you are not able to perform. You're not able to forward. Okay. A maximum path MTU is determined by the link layers. For example, the tunnel support a large MTUs. Okay, it can support anything more than that. Because everything, if it's just the tunnels, anything can be more than that. It can be 1005, can be 9600. But for the minimum, is only up to 1280, 1280. It's a bare minimum I can forward it based on my MTUs. So this maximum is determined by the link. You can up to 9600 byte as a jumbo frame. It's possible. I'm okay. So as long as you do not smaller than 1280, okay, it's not like IPv4. IPv4 the smallest is 64. Okay, 64 is the smallest. But for IPv6 the smallest will be on the 1280. That is the smallest. So okay, next we look into the transition technology. What are transition that we can use to transition from V4 to V6 or V6 to V4? How they're going to be coexist, or how they're going to interworking between the V4 and V6. So they have a multiple technology can support in between the IPv6 transitions. So that is the one. V4 V6 evolution strategy, they have either V4 V6 coexisting or the IPv4 V6 interworking. For the IPv4 V6 coexisting, they have one very famous is called dual stack. When dual stack, it means that for this device, you need to run both. You need to run on V4 as well as the V6 protocols. You need to run both protocols at the same time. And you have a 6/4 tunnels. So it means that you have two V6 on site, in the middle is V4. Then you can go for the V6 over the V4 tunnels. Under the V6 to V4 tunnels, they have a manual tunnels or the automatic tunnels. Manual tunnel is common, is on the GIE, 6/4 manual tunnels. For automatic, we have 6/4 tunnels, and also ISA-tap tunnels. Okay, that is more to the automatic tunnel. So you do not need to really define, just to enable this ISA-tap or 6/4 tunnel, they can easily form the tunnel by themselves. Okay, but the addresses need to be matched. Okay, they need to have a specific or special prefix. Okay, special prefix to provide the auto tunneling. Okay, for IPv6 interworking, they can using the NAT. So it means that NAT from V4 to V6. After that, NAT the next V6 back to V4. They call this as a NAT 6/4. That is one example that we show in this materials over here. Okay, we're going through all the tunnels as well as how the NAT 6/4 is being done. How the netting from V6 to NAT to be V4. Okay, but most of the time we are more focused into this V4 V6 coexisting. okay, coexist between, and how we're going to perform communication, we need to build a different type of tunnels. Or the easier way is just using the dual stack. But dual stack is you need to make sure that the devices that supporting using the IPv6. Some of the legacy device they might not support, then you might not able to configure as a dual stack. Alright. The first one we look into is on the v4, v6 coexisting. They call this as a dual stack protocols. Device must support v4, v6 as a dual stack. Interface connected to a dual stack must configure both v4 address and v6 address. They must have a IPv4 and IPv6. Okay, so it depends on, let's say you're using v4 can talk to each other, or can use IPv6 can talk to each other. So it means that they're running two protocols at the same time. So definitely in this case is possible. Let's say v4, you just go for v4. v6, just go for v6. Okay, so they do not have any interworking. This is just combined. There's just coexist. v4 is v4, v6 is v4, v6 is v6, v4 is v4. That they do not do any translation from here. It's just using your network or using my network. That's all. But this one, you have to make sure that all the devices support dual stack. Make sure all of them support on the dual stack that can be able to configure v4 as well as the v6. And your host as well need to be v4, v6 dual stack as well. So that is the easier way, but it's a bit costly. This one you don't need to think about the design as long as you just enable dual protocols. But it might occupy some of the CPU resources from your devices, okay? Because it's running both protocols. But these two are independent. They're not interference with each other. They stand alone. They're independent. Just that you need to run both protocols at the same time. So you'd be just wasting some resources of your CPU, memory, and so on. And 6/4 manual tunnels and the GIA tunnels be pretty famous from here. 6/4 manual tunnels. A type of the 6/4 manual tunnels, the source address and destination address must be manually specifying. It's deployed between the two border routers or between a host and a border routers. So it can be from host to host or can be between the border to borders. The most of the time we define this from the border to borders. Okay, between the two borders or between a host to the borders. So it means that in the middle over here, you're running as the IPv4. You build a tunnel from here. Okay, build a tunnels. Whichever information is v6, when you go into the tunnel, you add another IPv4 headers. Protocol number of the v6 is called 41. Okay, using 41 to carry the information. This is called a 6/4 GRE tunnels. So usually you send using send as a v6, but when you go into this, that is on the v4 only. So you should have a v4 source and destination to form the tunnels. Okay, IPv4 source and destinations to form the tunnels. But definitely on the tunnel, you should have a tunnel IP, IPv6. Okay, IPv6 address for you to guide the traffic go into this next hop. So in this case, they can go into the tunnel. To form the tunnels is v4. Okay, but the tunnel interface is under IPv6. So it is how they guide the traffic into the tunnels. So from v6 going to the v4 tunnels. This is how we call it as a v6 6/4 manual tunnels. Is that okay? That's one of the way. This is called the manual tunnels. Another manual tunnel requires a GIE tunnels. GIE tunnels. GIE tunnel is type of 6/4 manual tunnels. You also need to define. You just have to define this as a GIE. Okay. Actually, it will be very similar to 6/4. Just that the encapsulation are different. They encapsulate the GIE headers. Compared to now 6/4, it's just a IPv4 headers. One headers. But this time you add GIE headers as well as the IPv4 headers. You just add on a new headers inside the GRE tunnels. Okay, that is the differences. So how we're going to use the 6/4 GRE tunnels? They will just add on a single headers. Okay, add on single headers. Is okay up to this point? For this is all the manual tunnels. Okay, a manual tunnels. And the next we look into it is on the automatic tunnels. Automatic tunnels. 6/4 tunnels. A type of 6/4 automatic tunnels. 6/4 tunnel can be established between the two routers, two hosts, or a host to a routers. A 6/4 dedicated address, they have a specific address start from 2002 colon IPv4 colon 48. Okay, that has been fixed. It's already fixed this address you need to be using. So 2002 colon of your IPv4 address. Okay, this is where your IPv4 address. This is where your IPv4 address you will allocated to form the tunnels. Okay, so and this is how the tunnel is defined. So in this case, when the 6/4 that you build, you need to define these addresses, IPv4 addresses, inside your tunnel that need to be communicated. So in this case, they're also using the V4 tunnels, okay, V4 headers, but they can build themselves based on the addresses that you define. When this address has been configured properly, the tunnel will be automatically formed through the 6/4. Okay. So over here they have a FP. This FP is a format prefix. This format prefix will be 001. And the TLA and SLA over here, TLA is the top level aggregation identifiers. The value over here will be converted is in total is 13 bit. 13 bit then converted you'll be using the same value over here. So it means that this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this value. So this is a 2002. Okay. There's 13 bit, but I already fixed that is a value. And you have a SLA. This is a site level aggregator in identifier. This is up to whether you want to define or not. But most of the time, we just define this IPv4 address based on the interface, the IPv4 address from this interface, from the routers to routers. How you're going to build, where you build from. Okay, we will build the address from. Okay, so they have one example from here. Okay, did they show the examples? No. Okay, they did not fully show the example from here, but right for the IPv4 address, the address will be determined something like this. Let's say they have 2002 colon, then they will have A.B.C.D and double colon. Okay, so let's say your address from here is a 192.168.1.1. They put the 192.168.1.1 2002 colon, something like this, colon. So in this case, this is a special dedicated address to assign for this router's interface IP. You put it into your IP addresses to form the 6/4 public tunnels. Okay, so 6/4 tunnel can be connected to multiple 6/4. Okay, so you can using the address 1 colon 2 by identify using the site SLA ID. Okay, SLA ID. Site 1, site 2 are communicating to this single site on the other side. Okay, so you can using the SLA to differentiate which site that you belong to on the 6/4 tunnels. Alright, this is on the 6/4 tunnel number 2, and number 3 over here, you also can define as a 6/4 relay. A 6/4 tunnel enable interworking between 6/4 network and a IPv6 network. Okay, I have an IPv6, I have a 6/4 NAT2. Okay, this IPv6 also can be a relay. You can be using this as a relay for them to perform the communication back to this network or back to this network. Okay, it can be a relay tunnel as well. Okay, if a host in the 6/4 network they need to communicate with the IPv6 network. The next hop of this route must be configured as a 6/4 address of the 6/4 relay on the border routers. So you need to have a border routers over here to guide the traffic, how you it got up to back to the IPv6 network. Because 624 tunnel, they're using a special dedicated address. It might not understand based on the IPv6 addresses. That's why they need to have some sort of converters of the relay to relay this information back into your IPv6 environment. Okay, that is how we call this as a 624 relay. Okay, 624 relay. So other than this 624 tunnels, we also have another one is called ISATAP. Okay, ISATAP. For ISATAP, the full name is called ISATAP is called the Intra-Site Automatic Tunnel Address Protocol tunnels. So they also have a special address format they're going to be used. They have using they don't care about the first prefix. They care about the address format on your interface ID. Okay, interface ID. So they will have a 5E FE colon 0A01. Okay, followed by 0201. So this is what they are focusing into. Let's say you have an IP addresses from here. So let's say I have a 10.1.2.1. 10.1, this is 10. 1. Then followed by 2.1. Okay, 10.1.2.1. In front, I have a FE, 5E FE. So this is telling you that that is running as a ISATAP by using this MAC address. By using this prefix, I know that I'm using right now using the ISATAP. Okay, ISATAP. In front, it can be a link lockers. It can be the unicast, a global unicast. It can be converted to become the ISATAP tunnel addresses. Okay, for them to communicate in between the tunnel 1 to the destination, tunnel 1 to the destination PC3, and the PC to PC. So this one can be the host to a host to a routers, or router to a host. So it'll be more flexible compared to the 624 tunnels. Okay, so that is a multiple mode of the automatic tunnels they can build. But when you say automatic tunnels, you need to assign the dedicated addresses. Okay, dedicated address. Some of the mapping to your IPv4. Okay, so it depends which method you prefer. You can use support using automatic, or you can using the dedicated manual way. Okay, manual you have two choices: IPv6 to v4 tunnels or GRE. For auto, we have two choices as well: 624 tunnels and the ISATAP tunnels. This can be done by performing the tunnels going through the IPv4 environment. Okay, when you have IPv4 environment, you can specify ISATAP or 624 tunnels. And under the NAT64, NAT64 is just a protocol conversion technology that can flexible convert packet between v4 and v6. NAT64 map field in v6 packet to field in v4. So data packet converted on the edge between the two nodes. So from v6, when I go to v4, I just doing the NAT6 to 4. On the other side, it's just NAT4 to 6. So just convert whichever I have v6 back to v4. And v4 translated to v6 and vice versa. This is called the NAT64. So you must have one called conversion gateway to doing all this translation. Translate whichever you have in v6 back to v4 and v4 back to v6. Okay, that is called a NAT64. So far, any question up to this point? So these are all the different tunnels. And the next one, we are going to go for the v6 configuration command. But before we go to this, let's take a break. Come back, I will share you the config file. We do it together, okay, on the v6 configuration command. After the break, then I'm going to show you how you perform this GRE tunnels.